Hello everyone, I am KVMS Lokesh from second year CSCB EVIT. In this session, I would like to give a brief introduction on augmented reality. Let us see what is augmented reality. Augmented reality is a technology that overlays digital information on top of the real world, allowing users to see and interact with virtual objects as if they were part of the physical environment. Augmented reality typically works by using a camera or other sensors to detect a user's location and surroundings and then overlaying virtual information such as images, text, or animations onto the real world. The overlaying virtual information such as images, text, or animations onto the real world view displayed on the screen. This can be done through a variety of devices such as smartphones, tablets, smart glasses, or headsets, which provides users with an immersive interactive experience that enhances their perception of reality. Some common applications of augmented reality includes gaming, education, training, marketing, and navigation among others. Now and then we are seeing augmented reality in our daily lives, such as in gaming sectors such as Pokemon Go game, which is based on our real world, that gives Pokemon avatars to catch by basis of the real world. And then in Marvel movies such as Avengers, we see the Jarvis artificial intelligence which provides the information based on the real world and superimposes to the user. And then Snapchat filters. We use Snapchat filters by editing our real world face through the extra filters. This is nothing but augmented reality. Now let us see when and where the augmented reality was discovered. Augmented reality has its roots in the field of computer graphics, which emerged in the 1960s. In 1968, Ivan Sutherland, a computer scientist, created the first head-mounted display, that is HMD, that could superimpose computer-generated graphics onto the real world. This paved the way for the development of augmented reality technology, which was initially used for research and military applications. In the 1990s, the first commercial augmented reality systems were developed, and in 1992, a researcher named Tom Farrell coined the term augmented reality to describe the technology. That means the augmented reality is based on the real world, but with some external features. The first augmented reality systems use specialized hardware such as head-mounted displays and optical sensors to overlay virtual information onto the real world. In 2000s, augmented reality began to traction in industries such as automotive design, where it was used to visualize and manipulate digital models of cars. In 2008, the release of the first augmented reality app for smartphones called Wikitude opened up new possibilities for augmented reality on the mobile devices. The development of markerless AR technology in the 2010s, which uses computer vision algorithms to detect and track real-world objects without the need for specialized markers, made augmented reality more accessible and led to the development of popular applications such as Pokemon Go and Snapchat filters. Today, augmented reality is being used in a variety of industries, including entertainment, education, healthcare, and manufacturing, and is expected to continue to grow and evolve in the coming years. Now let us see how this AR works. To augmented reality works by overlaying digital information onto the real world through a device such as smartphone, tablet, or smart glasses. It allows the users to see and interact with digital content, and then it appears to be a part of the real environment. There are some key components that makes the AR possible. They are camera. A camera required by the augmented reality to capture the real world environment and display it on a screen. And then sensors. AR devices typically have sensors such as accelerators and gyroscopes that allow them to detect the position and orientation of the device in space. And then software. Augmented reality software uses the camera and sensors to analyze the real world environment and overlay digital content onto it. Display. The digital content is displayed on a screen, typically a smartphone or a tablet, but it can also be displayed on smart glasses or other wearable devices. Once these components are in place, augmented reality works by using computer vision algorithms to detect objects and features in the real world. The software then uses this information to place digital content on the top of the real world environment, creating the illusion that the digital content is part of the real world. Users can interact with the digital content using touch, gestures, or other input methods, and the software will respond accordingly. For example, let us take our Snapchat filters. First, we need to detect our face, so we use the camera. And then, to find our face and the exact location, And to dim or brightness the trends, we use the Snapchat filters. And then the Snapchat software allows us to edit our photo as we like. And then finally the image is captured and it is displayed to us. These all contribute the augmented reality. Now then, let us see the types of augmented reality. There are typically four major types that are marker-based augmented reality, marker-less augmented reality, projection-based augmented reality, and superimposition-based augmented reality. Now let us see them one by one. Marker-based augmented reality. Marker-based augmented reality is a type of augmented reality that uses specific visual markers to overlay virtual content onto the real world. These markers can be anything such as QR codes, barcodes, or simple shapes to complex patterns that our augmented reality system can be recognized. To use marker-based augmented reality, a camera-equipped device such as smartphone or tablet is required, along with an augmented reality application that can identify and track the markers. One of the advantages of marker-based reality is the ability to provide accuracy and stable tracking as the markers provide a clear reference point for the augmented reality systems to be followed. However, the use of markers are also limits the flexibility of AR experience, as the system can only overlay content on the specific markers that it recognizes. So, in order to overcome the limitations of marker, we have the markerless augmented reality. Markerless augmented reality is a type of augmented reality that does not require specific visual markers to overlay the virtual content on the real world environment. Instead, it uses computer vision techniques and other sensors such as GPS, accelerometer, and gyroscopes to detect and track the real world environment and overlay virtual objects on it. Markerless augmented reality is typically more flexible than marker-based AR, as it can be used in a wider range of environments without the need for specific makers. This makes it useful for a variety of applications, including navigation, interior design, and entertainment. We can compare the marker-based and markerless AR by taking example as KinderJoy provides AppleDo app for children to use virtual world known as Dream Room. This is possible only through QR codes. But whereas markerless AR, we can take example of Snapchat filters. Just by taking a picture, we can edit as we like without any need of QR codes. Just by altering the real world. And then projection-based augmented reality. Projection-based augmented reality is a type of augmented reality that projects virtual content onto the real-world surfaces such as walls, floors, objects using a projector. The projected virtual content can be static images, videos, or interactive animations that respond to user input or changes in the real-world environment. Projection-based augmented reality systems typically use depth sensors such as Microsoft Kinect to detect the track the real world and environment and adjust the projection accordingly. This allows the virtual content to be projected onto the complex and irregular surfaces such as curved walls or furniture. Projection-based AR is often used in advertising, entertainment, education, where it can provide interactive and immersive experiences for users. To understand projection-based augmented reality well, let us compare it with the projector. In projectors, we may display only the words or PowerPoint softwares, but in projection-based AR, we can take it to the next level by altering the real-world applications. One advantage of projection-based augmented reality is its ability to provide large-scale and high-impact visual displays. And then superimposition based augmented reality. It is an augmented reality in which involves overlaying digital content such as images or animations onto the real world in real time. This is achieved through the use of cameras and sensors on mobile devices or AR spreadsheets, which can track the position and orientation of the devices in 3D spaces. Superimposition in augmented reality can be achieved using various techniques such as marker-based augmented reality, markerless augmented reality, and SLAM. These techniques use different approaches to track the superposition and orientation of the devices, and each has its own strengths and weaknesses depending on the use case. Now let us come into the applications where the augmented reality can be applied. Let us have a look. Medical training. Augmented reality technology has a major application in medical studies. It helps the learners to handle expensive equipments like MRI scanners. Medical and surgical training is well conducted and carried out through the AR headset in 3D image format. Interior design. In recent days, augmented reality is widely used in visualizing the final product even while in the construction phase. One can choose their favorite paint color or select their desired furniture or wall hanging even without buying it, which perfectly suits their taste. In education, with the advent of augmented reality technology, the class learning has become an interesting for students across the world. With rich learning environment, substances can stay anywhere across the globe and attend a solar system class. Entertainment. Augmented reality technology is first used in television broadcasting. Augmented reality has wide uses in entertainment programs, sports, and computer games. It helps to build a deep connection between the user and digital character. Game statistics or techniques are communicated to the audience to get engaged and entertained. Retail industry. In the modern world, shoppers can use their smartphones to check out various products, compare their prices just by scanning the mobile app, and details of the products and descriptions can be captured. In auto sector, user can customize these spare parts and color with even touching the object. Now let us have a look of benefits of AR. As there are many emerging new technologies, let us have a look what are the benefits by learning this augmented reality. First, improving the quality of production standards. Education and training. Visualizing companies can use augmented reality superimposition to show customers how products would look in their home or office before they make a purchase. Augmented reality solutions allow for the improvement of production process quality by accelerating productivity safely, reducing the errors, and guaranteeing greater compliance with company standards. This technology is particularly useful for checks and inspections, two key processes when it comes to ensuring the highest possible product quality. Hybrid smartphone headset applications, for example, make it possible to carry out checks and inspections in difficult and complex settings with the support of experts who are connected remotely to the assist technicians, and then reducing the production and service costs in the field. These many benefits of augmented reality technology includes a reduction in costs in various sectors and application contexts. This is made possible through direct intervention in optimizing costs, whether as a result in increased productivity or improvements in process quality. Augmented reality makes it possible to reduce design production and maintenance costs. For example, using augmented reality to maintain machinery allows problems to be solved faster and more efficiently. Refining training and skills sharing. One of the benefits of augmented reality for benefits is improvement it can bring to the training, a fundamental quality for any company. Augmented reality solutions can be exploited to improve the skills of the workforce with staff able to receive precise and specific instructions, and then improve industrial safety standards. Augmented reality makes it possible to improve safety in a number of areas linked to industrial sector. First and foremost, operators can protect themselves from handling risks by interacting with production environment more safely. It is also possible to take advantage of physical and organizational benefits thanks to the improved environments of employees with AR solutions. Optimizing the product assembly process. Another benefit of augmented reality technologies is the optimization of product assembly. This type of work requires operators to be particularly meticulous, which can be challenging when hundreds of parts need to be assembled quickly and correct flowingly instructions in the technical document. The use of augmented reality allows this process to be made more interactive and simpler, making assembly information clear and supplied to the operator through an AR headset. This solution allows the employee to focus on instructions in a long and complex file of the text. And then let us see what are the challenges faced by the augmented reality. Technical challenges. One of the most significant challenges of the augmented reality is the technical hurdle it presents. Augmented reality requires significant computing power to overlay digital content on top of the world. User experience. Augmented reality can be complex to use, and creating a seamless and intuitive user experience can be challenging. Augmented reality experience is both helpful and enjoyable. Integration with other technologies. Augmented reality must integrate with other technologies such as hardware devices, software applications, and networks. Privacy and security. Augmented reality applications often require access to sensitive user data such as location information, camera feeds, and personal information. Content creation. Creating compelling and relevant content for our applications can be a challenge. Developers must ensure that the content is engaging and useful, and developing such environment can be challenged. Now let us see what will be our future if we learn this augmented reality. Augmented reality in manufacturing. It can be used to improve productivity and quality control in manufacturing. For example, workers can use augmented reality to see instructions overlaid onto the workspace they are working on. And then augmented reality in entertainment. Augmented reality can be used to enhance entertainment experiences. For example, users can use augmented reality to view characters from their favorite movies or games in their own surroundings. Augmented reality in healthcare. Augmented reality can be used to assist with surgical procedures, medical training, and patient care. For example, doctors can use augmented reality to project virtual images of organs onto a patient's body. Augmented reality in education. Augmented reality can be used to create immersive learning experiences. For example, students can use augmented reality to explore historical sites or view 3D models of scientific concepts. To sum up, augmented reality has the potential to revolutionize the way we interact with digital content by seamlessly integrating virtual elements with the real world. Augmented reality technology can enhance our experiences and provide new ways of learning, creating, and communicating. For gaming and entertainment to education and training, the applications of augmented reality are vast and varied. With the increasing availability of smartphones and smart glasses, augmented reality is becoming more accessible and widespread. As augmented reality technology continues to develop and mature, we can expect to see even more innovative and exciting uses of this powerful tool. Thank you for your attention, and I hope this presentation has given you a better understanding of augmented reality and its possibilities. Thank you.